Welcome back, geometry students. In this video, we are going to work some problems related to circles and inscribed angles. In our first problem, we see one of these hourglass sort of looking shapes inscribed into a circle. What this actually is two inscribed angles that open up to the same arc. And actually, in letter A, we're asked to do a proof. We're asked to prove that angle ADB, this one, is congruent to angle ACB, because we're told with theorem 47.3 that inscribed angles that open up to the same arc are congruent to each other. So here's how I would do this proof. I would start with some statements on the left and reasoning on the right. First of all, we're going to state that angles ADB and ACB are inscribed angles. That's our one given. And then we're going to note that the measure of angle ADB is equal to 1/2 the measure of the arc that it opens up to. That was theorem 47.1. The measure of an inscribed angle is equal to half the measure of its intercepted arc. Okay, so that's what this is saying. Next, we're going to say that the measure of angle ACB is the same. It's 1/2 the measure of its intercepted arc. And now, because this is equal to 1/2 the measure of AB, and let me move this down a little bit, this is equal to 1/2 the measure of AB, because both of these are equal to the same thing, I can use the transitive property of equality to say they're equal to each other. ADB equals ACB. And then finally, when I have two angles that are equal to each other, that means that they're congruent to each other by the definition of angle congruence. So that's how I go about proving letter A. Let's move on to letter B. You need to find the value of y. This one's more of just a thinking it through problem than an actual math problem, though, like arithmetic problem, because all I need to do is think through what's going on here. Notice that this this line segment right here passes through the center of the circle. That makes it a diameter. And I know something about diameters from our previous lesson. If an inscribed angle intercepts a semicircle, or in other words, if I make the whole triangle, one of the sides of my triangle, the longest side, is going to be the diameter of the circle, then it is a right angle. Then the angle is a right angle. Okay, so what does that mean? That means that this angle here is a right angle. And that means that this is an isosceles right triangle, because I have these marks too showing me that these two angles are equal. So if this is 90, and then I need to say 2 of angle y plus 90 equals 180 degrees, because y plus 90. Well, what number times 2 plus 90 equals 180 degrees? If I wanted to use arithmetic, I could do it. I actually already kind of know the answer, but 180 minus 90 is 90. So I could subtract 90 from both sides. 2y equals 90. Divide both sides by 2. I get y equals 45. Those are 45-degree angles on the edges there. Okay, that's the value of y. And the way I was able to figure that out was because I knew that this was a diameter, or in other words, my angle opened up to a semicircle. The intercepted angle is actually a semicircle. So that means that this side has to be 90. Each of these have to be 45. Let's do letter C. We're looking for the value of x, and here I have one of those hourglass looking shapes. That means that this is going to be two angles that open up to the same arc. And if two angles open up to the same arc, which I can see these clearly do, they have to be equal to each other. So I could just say, so because these angles are congruent, 2x plus 10 equals 3x minus 7. I'm going to subtract 2x from both sides. I'll get 10 equals x minus 7. X equals 17. Just by way of checking, 2 times 17 is 34, plus 10 is 44. 3 times 17 is 51, minus 7 is 44. So I know I did that right. All right, letter D. Find the measure of angle A in this. Well, here I'm going to use a different theorem. I'm going to use this theorem that says if a quadrilateral is inscribed in a circle, it has supplementary opposite angles. So that means that C plus A is going to equal 180 degrees. That means that x minus 18 plus x plus 16, if I add these angles together, equals 180 degrees. And then let's see, I'm going to combine like terms. So I get 2x minus 18 plus 16 is minus 2 equals 180. I'm going to divide everything by 2. X minus 1 equals 90, or x equals 91. Okay, so if x equals 91 and I'm looking for a, it's going to be x equals, let's see, or I'm sorry, a, the measure of a, let's see, do I have an angle? I'm going to just grab one of these angle symbols. So the measure of angle A equals, and it's going to be 91 plus 16 is 97, 107 degrees. All right, moving right along to letter E. Here, let me just fix my font size. There we go. All right, letter E. Not sure what happened to my font size. Let's try that again. Letter E. Okay. A radar screen in an air traffic control tower shows flight paths. The control tower is labeled L. Points M, L, and P mark the flight path of a commercial jet. M, L, P. Find the measure of M, L, P. This one is a bit of a puzzle, isn't it? Now, one thing that you can never assume, it looks really easy to say, oh, there must be like alternate interior angles going on here. Well, these are alternate interior angles. They're not alternate interior angles across on either side of a transversal that crosses parallel lines. So I can't say that MPL is congruent to PON because of that. What I can note is that PML opens up to the same angle. Let's see, PMN opens up to the same angle as NOP. So I know that this angle here has to be 27 degrees. Let's see, what else do I know? Well, I don't know any of these interior angles here. And I can see that this is clearly not, L is not the center of the circle. So I can't say anything about like this 94 degrees, meaning anything for these angles. But I do know that the angles that like N and P open up to, N is going to be half of 94 and P is going to be half of 94. So let's just put some things on here that'll be helpful for us. I know that N is half of 94. What's half of 94? That's going to be, let's see, 47. So I'm going to write a 47 degree angle here. And we're going to just shrink the size of this font a little bit. There we go. Make it fit in there. Okay, so that's a 47 degree angle. And this is a 47 degree angle. And also, because I see that NOP opens up to the same angle as PMN, I can see that this up here has to be a 27 degree angle. Now, I'm looking at a triangle, and I know that the triangle angle sum theorem says when I add 27 plus 47 plus MLP, it has to equal 180. And I think I figured out enough of this. So 27 plus 47 plus whatever MLP is, the measure of angle MLP. Just get that in there. That's all going to equal 180 degrees. 27 plus 47, that's going to be 74, plus the measure of MLP equals 180. And I'm going to subtract 74 from both sides, so I get the measure of MLP equals 106. That's a 106-degree angle in there, and then all three of those angles will add up to 180. That is how you work these sorts of problems. Some of them are really puzzles. Letter E was kind of a puzzle, but if you think about the theorems that you know enough and just puzzle it out, you'll be able to figure these out. All right, you can work the problem set for next time.